All right, you ready to move ahead? Let's we're gonna get through 2.1 and 2.2 for sure, and I'd like to get through part of 2.3. All right, so solving. So we're in chapter 2. We're totally changing gears. We're dealing with equations now, which means there's an equal sign in the middle here. I'll write it a little bigger. So it's x plus 10 equals 41. So an equal sign is like the middle. I'll put a wall there. I think I encourage you to do that just to be real clear. That's the separator. You got a left side and a right side. Reminds me of that old riddle I heard when I was a kid. And it confused me when I was a kid because I thought like a kid. And the riddle goes, which weighs more on a scale? One side, 1,000 pounds of gold put on the scale. Other side, 1,000 pounds of feathers. Feathers. Which one weighs more? Well, yeah, is that a hard question, Mr. Heron? No, it was for me as a kid. I was like, I don't know. They're both 1,000 pounds, but that's a lot of feathers. I don't know. But yeah, I mean, you're right. They're equal. That's the whole point. They're both 1,000 pounds. That's kind of the point of an equation. They would look very different, right? 1,000 pounds of gold, 1,000 pounds of feather. They look very different, but they are equal weights. Well, that's what we have with x plus 10 and 40. Those don't look the same. X plus 10 doesn't look like 41, but they are equal. So that's the point of an equation, how two things that look very different are in fact equal. That's what they're saying. So what that means then is if I was to double the amount of gold on the gold side and double the amount of feathers on the feather side, they'd still be equal, wouldn't they? Because they were equal before and I treated them the same, they're going to be equal afterwards, aren't they? Well, that's the same thing with an equation. They're equal before. Whatever you do the same thing to both sides, they'll be equal afterwards, right? If they were equal before and you treat them the same, they got to be equal afterwards, don't they? It's called the principle of equality. So whatever it's called, you sense it's true. And so that's what we'll use. Now, the other main thing here is we're trying to find out what number could you plug in there. What could x be? Add 10, you'll get 41. Well, you know, you don't need to solve some equation. You just know this is so easy, you can do it off the top of your head with just a casual glance. They'll get harder, obviously. So in order to handle them when they're harder, let's learn the technique. The technique is to really isolate x, isn't it? It's to get x alone. X is like yelling out, I want to be alone. X is a big loner. I want to be alone over here. So what do we do? What do we do to isolate x? What do we do to get x alone?
You subtract 10.
Yeah, you always do the opposite of whatever's next to x. Huh? What's next to x is an add 10, so the opposite of that is subtract 10. And whatever you do to one side, you have no choice but to do the same thing to the other. Because you got to keep the balance, huh? You got to treat them the same. They were equal before, treat them the same, and still be equal. Draw your line. So you see what I'm doing? The red up there, well, I changed part of its color, huh? The red up there is the original. And the black is what I did to it. It's the action I'm taking on both sides of the equation, right? So the red is the original state. I'm subtracting 10 from both sides. Now comes the result. Draw the line to show now comes the result of the action I took on both sides. What's the result? Well, over here, these cancel. That was what we wanted because we wanted x alone. What happens on the other side? 31. There's the answer, which we knew all along without doing anything. 31 is the number that you could put in for x that would make the thing true. And we found that by doing the opposite, what's next to x, to isolate the x. All right, so they're starting simple. They're going to get much harder. So x plus 8 equals negative 10. There's the wall. Try that one. X is saying what he's always saying. I want to be alone. Get rid of whatever is with the x. Okay, so what do we do to get the x alone? Yeah, do the opposite of adding 8, you subtract 8. Both sides cancels out. X is alone. What does it equal? Negative 18. Good? Why don't those two negatives make a positive? Because they're not multiplying or dividing. Two negatives that multiply or divide become a positive, but two negatives that like add, subtract, you just think about money or football, gains and losses, right? Football team loses 10 yards and loses 8 yards, they lost 18 yards. If you lose $10 and then you lose $8, you lost $18, right? All right, so we'll leave it at that. If you, I don't know if you think about sports, but if you, well, I was just losing money made me remember. Never own horses. If you, yeah, let me tell you though. You know how to make a small fortune in horses? You start with a large fortune. That's what you do. So I'm just telling you about my horse problems, about losing money. Last night, as we get into bed, my wife is telling me about the thing with one of our horses. I own now one horse. Thankfully, I'm down to one. But it got sick yesterday, or no, like a week ago. And they horses can't, here, probably more than you want to know about it. Horses can't throw up. Did you know that? That's probably more information than you wanted to know, huh? So they can die from that when they get a little infection. And then you ship them over the vet, and then the vet just rings up bills for you. So as we're going to bed last night, my wife said, yeah, I went and picked up the horse, and my daughters are obsessed with horses. I went and picked up the horse, and I said, okay, honey, I was really putting my head on the pillow. I'm like, so how much was that? She's like, $850. And I'm like, really? $850? I've got one income here, with 5 children. $850. She's like, yeah, that's actually a pretty good deal for a week at the vet with the horse. I mean, it's a wonderful deal. Great. Anyway, so there's my little life story and losing money. Horses. X opposite, and that'll get X alone. So X plus 16 equals negative 12. So do what it takes to get the X alone. All right, plus 60. So what do you do? So X wants to be alone. What do you do to get X alone? We subtract 16. And there it is, X alone. Other side, it's a big loss of money again. What is that? Minus 28. Good? All is well? Easy? All right. Harder is what I mean by better. Better for me to do for your benefit. All right, so X minus 2/3 equals 4/5. All right, so what do we do to get X alone there? Yeah, I'm going to add 2/3, right? Got to add 2/3. X is saying I want to be alone. Add 2/3. All right, so that's gone. X is now. How do you add those two? Good job. Yeah. Did you know whenever you add, subtract, you fractions, you have to get common denom is required. But when you multiply, divide fractions, no common denominator needed. No common denominator needed. Do you know that? Are you clear on that difference? Right? When you add, subtract fractions, you've got to get common denominator. Multiply or divide is not required. So, all right, so we're adding here, so we got common denominator. So what are we going to do to get common denominator on this one? Yeah. Multiply top and bottom by the other one, huh? Exactly right. So this one, top and bottom by 5. That'll become 10/15. This one, top and bottom by 3. This will become 12/15. Is that good? So you make both denominators 15 by multiplying by the other guy. And then we can add those together. And you get what? 22/15. And that's it. We're done. It's okay to have the top bigger. That's okay. Good on that? Makes sense? That's probably the worst one in the section right there. All right. Oh, no. Yeah, no, I'm kidding. Yes, totally. Absolutely. Yeah. Yeah, no, that's just for the homework. You're gonna know. Yeah, totally. You're totally right. Not a funny joke. Yes, you can use your calculator on the test. Not a cell phone though, right? Not a cell phone. You got to have a calculator that's not a cell phone, right? On that. All right, let's try that one. If you need to buy one, the Casio Natural Display, you'll like that one a lot. But don't get it if you already got a good one. All right, so got to solve for x. So give it a try. They want the final, look, here in the blue, you can tell the format they want the answer in. They want it as a fraction, meaning they don't want a mixed number in the end. They want a regular fraction. They don't want a mixed number. So try that. Get a final answer as a fraction. You know what I would probably do is I would probably make it a decimal in the beginning. It's easier to work with decimals and then convert it back in the end. You don't have to. There's a million ways you could go. That's probably about the easiest. You know, right? What if I said I've got $4 1/4? What is that? That's $4.25, huh? A fourth of $1, 25 cents, right? But if you're not sure, just take your calculator 1 divided by 4, and it'll tell you 0.25. You can always just convert the fraction part to a decimal on your calculator by just dividing, right? 1 divided by 4 is 0.25. So 4 1/4 is 4.25. Now, I've converted to decimal. Going to have to convert back in the end. How do I solve for x now? Yeah, subtract the 4.25 from both sides. X equals, so $7, take away $4.20, use your calculator if you want to. Isn't it $2.75? $2.75. Now, we can't leave it in decimal because they want a fraction. So how do you convert that to a fraction? 75 cents, $2.75, $2 and what part of another dollar? 75 cents is what? 3/4. Ah, but we can't leave it that way either. But that's an easy conversion from there, isn't it? Right, 75 cents is 3/4 of a dollar. What do you do now to convert it to a normal fraction? Multiply the bottom, add the top, huh? And the denominator does not change. It was fourths before, it'll still be fourths. It says 2 times 4 is 8, add 3 is 11 fourths. There it is. Questions I can answer on that one? There's a lot of other ways to do that. I think that's about the easiest. Okay.